So vector concept is done. I mean, vector you have understood. I'll assume that you know unit vector, ij, their usefulness to write a vector. It may be velocity vector, maybe force vector, whatever. Displacement vector also there. Now, when you are going to discuss motion in a plane, I need to remind you, I think I will remind you the concept of position vector once more. What is position vector of a point? This point A has a position vector A. I mean, only one position vector is possible, that is A. The point B has position vector B. So from origin, if you have joined the point A, then this will represent the vector A and this one will represent vector B. So what you have assumed, let position vectors of the points A and B be A and B respectively. Then OA equal to, as shown in diagram, OA equal to A vector and OB equal to B vector. Now, suppose the particle goes from A to B, then AB represent the displacement vector. What is happening there? Particle goes from the point A to the point B, then AB represents displacement vector. How to get that displacement vector? We use triangle law in triangle OAB. What do you observe? OA plus AB equal to OB. Therefore, AB vector is OB minus OA, B minus A. Now, AB is the displacement vector, which is nothing but position vector of point B minus position vector of point A. If the particle goes from P to Q, say, then point P is here, Q is here, PQ is the displacement vector. How to write PQ vector then? PQ vector going to be position vector of Q minus position vector of P. Very simple concept, and everything is understood with the help of triangle law of addition of two vectors. Now, when a particle moves on a straight line, we need not do vector application over there. But when you consider motion in 2D, motion in 2D is motion in plane, motion in 3D is motion in space. Particle moving in 2D, it means particle can move in a straight line over there. It can move in a curve also. 2D means it is made of x and y coordinate system. say particle goes this manner in a curve. This is not the case of motion in one dimension. Instead, you can say that it is motion in two dimensions, which is made of two different dimensions. Dimension means that coordinate axis. X-axis and y-axis, we take unit vector. Along x-axis is I cap, along y-axis it is j cap. When the particle goes from A to B, then from one point to another point, its direction of velocity is going to be changed. At this point, velocity in one direction. At this point, velocity in one direction. Here in another direction. What is that direction? It is along the curve, tangential to the curve or perpendicular to the curve. Everything will be discussed now. We are going to do all these things step by step. So in two-dimensional motion means this two dimension is made of two one dimensions. Particle is situated at A, it means it has some position vector. It has some coordinate, better to say. This is x1, y1. And suppose the particle is at x2, y2. Then, as you have seen before, in representation of vector in 2D and 3D, wave vector can be written as x1 I cap, y1 j cap. OB vector is what? x2 I cap, y2 j cap. Then AB is the displacement vector. A to B, if you join, then this is going to be the displacement vector. Okay? Displacement vector is not coincident with direction of motion or direction of velocity. It is just a direction. It may coincide with the direction of velocity or direction of motion at a particular point, but in general, that is not true. AB vector, if we want to write, it will be what? This is OB minus OA. If you subtract this from this, it is going to be x1 minus x2 I cap, y1 minus y2 j cap. We can take this one delta x, change in x, and this one delta y. And AB vector, this displacement vector, we can denote by the letter delta r, change of position. Okay? This is in terms of coordinates of 2 points. I am not considering end of the path and beginning of the path always. So I will be considering any arbitrary point on the path. Okay? One arbitrary point to another arbitrary point. Okay? So let me draw coordinate axis again. Let us start this again, where I am going to find the displacement vector on a curve and then the direction of velocity vector. Okay? What is the direction of displacement vector here? In this diagram, displacement vector is along AB, from A to B, isn't it? But this is very much specified. We have taken 2 points. One is the starting point, the other one is terminating point. It can happen anywhere on the curve. Okay? Let me take the same curve here. This is a point. This is a point P and this is P dashed. This point P has the position vector equal to R, and this point P dash has position vector R dash. This is R vector and this one is R dash vector. P dash, this point here, this is R dash vector. So what is displacement vector here? PP dash is the displacement vector. Okay. Let the particle be at the point P in time t and at P dash in time t dash. Okay. P point, its position vector is R, the way it is shown, and this is R dash. Then displacement vector, as I told you earlier, here displacement vector will be delta R, that is R dash. This part is R dash minus R. Clear? Once more, that OP plus PP dash equal to OP dash. So PP dash equal to OP dash minus OP. So this is delta R, which is equal to delta R dash minus R. Okay, this is displacement vector directed from P to P dash. Displacement vector, direction of displacement vector, direction of delta R is along PP dash. Okay. Now the way it is shown, that point P has coordinates say x, y, and P dash has coordinate x dash, y dash. Then delta R, how can I write? Like the previous example, delta R, we write once more R dash minus R, that is delta R along x-axis and along y-axis, that you take as delta x I plus delta y j. Okay, delta x I, delta y j, and this part going to be what? X dash minus x I plus y dash minus yj. Okay, the way I have shown you earlier. Okay, this is delta x is x dash minus x, delta y is y dash minus y. Now, if we want to define from this displacement vector, if you want to define average velocity vector, what is going to be that? That average velocity is like one-dimensional motion. Average velocity will be what? Average velocity is delta v. Delta v is the average velocity. This is a rate of change of average displacement. This particle goes from P to P dash in time delta t. Time, that t dash minus t is delta t. It was here at time t, as we have assumed before, at this point at time t dash. So this is delta t. Delta v, how can I define then? This is delta r minus delta t. Okay. Now Delta r is what? Delta r we have written this form, that is delta xi plus delta yj that divided by delta t. Therefore, delta v going to be delta x by delta t I cap, delta y by delta t j cap. Isn't it? This delta x by delta t is average velocity along x-axis. Vx is what? Delta x by delta t, that is velocity along x-axis or component of velocity along x-axis, and this part is Vyj. Vy is delta y by delta t, this is velocity along y-axis. Okay, Vx, Vy. Now, delta V, see, here vector is in this part. Delta r by delta t. Delta r is in this direction. So, what is the direction of delta V? Direction of delta V is along delta r. This is very important to note. The velocity vector is along displacement vector. Motion in one dimension, what you have seen? This is always true. When particle moves in one dimension, then velocity vector is directed along displacement, or velocity is directed along displacement. We have to say that. In 2D also, similar is the case. But when we find acceleration, we will find different directions. Okay, let us analyze this velocity vector first. Delta V you got, it is directed along delta r. Now, if we, just a minute, if we want to write, if we want to find velocity at a particular point, then that velocity will be termed as instantaneous velocity. What is instantaneous velocity here? Instantaneous velocity means velocity at a particular instant. We have to understand the case first, that instantaneous velocity. What is that? Just a minute. Instantaneous velocity will be velocity at a particular instant. Now, to find the instantaneous velocity, what you need to do here, that instantaneous velocity v can find by using this limit delta t tending to 0 delta r by delta t. But you have to make delta t tending to 0. Okay? Delta t tending to 0, delta r by delta t is the instantaneous velocity. This is called instantaneous velocity. So, this thing is going to be limit delta t tending to 0, substitute the value of delta r, that is delta x by delta t I, delta y by delta t j. Separately, if you apply limit on this and limit on this, then this is going to be dx by dt I plus dy by dt g. Okay, and simply rewriting this expression again, we can write v equal to, you differentiate the vector directly, you can get velocity, or you write this as dx by dt I cap plus dy by dt j cap. Okay, the concept is clear. Now, how to get the net velocity of the particle? Even this also you can write as Vx into I cap, Vy into j cap. Here, Vx, Vy are instantaneous velocities along x and y axis respectively. Okay, so instantaneous velocity is also instantaneous. Here it was average velocity. This is average velocity, delta x by delta t, and this is also average velocity. Average velocity, but here this will represent instantaneous velocity along x-axis and y-axis. Mod v will be what? As seen before, it is vx square plus vy square, and if you go by 2D representation of this velocity vector, v vector along x-axis, the component is vx, along y-axis, the component is Vy, this angle be theta, then tan theta going to be Vy by Vx, like vector, it has two components, y component by x component, theta going to be tan inverse Vy by Vx. Now a question arises, what is the direction of instantaneous velocity? How to find the direction of instantaneous velocity? As discussed before, average velocity, that if you write v or whatever, delta v by delta x, delta r by delta t, delta r average velocity, v average is delta r by delta t. This is directed along delta r. But instantaneous velocity won't be along v average. Why do you say that? Let me prove this, why it is not directed along v average. Very interesting. Just particles motion we are going to consider on the path only. This is very much conceptual topic in physics. This concept is essential for all of you. Particle is on this path going. At any time t, the particle is at P. This is after time t or at time t, whatever you say. It is, say, P1 at time, after time delta t1, P2 after time delta t2, and P3 after time delta t3. Okay, time required from P to P1 is delta t1, from P to P2 point is delta t2, and this is delta t3. Okay, Now, when it goes from P to P dash, the displacement vector is directed along PP1, isn't it? Let me clarify with a better diagram here. Just I am changing the diagram a bit here for your better understanding. It's like this. Okay, particle goes from the same diagram only, just taking this manner and this manner. When it goes from P to P1, velocity vector directed in what direction? That is along PP1. When it goes to P2, velocity vector directed in what direction? This is along PP2. When it goes to this point P3, velocity vector directed along PP3, average velocity. Okay? But these are times. From P to P1 time we have taken what? Delta T1. P to P2 what we have taken? That is delta T2. P to P3 we have taken delta T3. Now suppose you are approaching the point P from P1. You are approaching P from P3. The average velocity is well defined and time is too large. Average velocity along V average is along what direction? V average is along PP3. It's distinct. Particle approaching from P to P2. V average is along what direction? V average is along PP2. You are going very close to the point P. Particle is going from P to P1. V average is along PP1. What you are doing actually there? You are approaching the point, now just opposite term you consider. You are approaching the point P from P3, then from P2, then from P1. Gradually, when you are tending the point P, from any other point, when that point is very close to P, when the point is very close to P, that delta T1, no, here time was delta T3, it is very large. Delta T2, this is also large. Delta T1, large but smaller than these two. I mean, delta T1 is smaller than delta T2, smaller than delta T3. When the point is very close to P, that is delta T tending to 0, then you can see that this PP3 to P2 to P1, then it is becoming tangential to that point. Okay, when delta T tending to 0, that arbitrary point P3 or P1, say PP1 is along the tangent at P. So, in motion in 2D, instantaneous velocity at a point is tangential to the curve. Tangential to the curve at the point. The best example you will find in circular motion. Particle moving in a circle. At an arbitrary instant, say here, what is the direction of velocity? This will be tangential. Not along the curve, it is always tangential. At this point, it will be tangential. Everywhere the particle situated here, its direction of velocity, this is very important. This is not the case of average velocity. For average velocity, it is directed along the displacement vector, but for instantaneous velocity, it will be tangential to the path always. Clear? Similarly, if you do it for acceleration, what will happen? If you go for acceleration, average acceleration will be what? Acceleration in 2D. Average acceleration will be what? That is A equal to delta V by delta T. So you better write A average, otherwise it will be mixed with the instantaneous acceleration. A average is delta V by delta T, and quite obvious that A average is directed along delta V. If I tell you on this path only, the same curve I am trying to take, on this curve only, when the particle has velocity v1 at this point and v2 at this point, or say v here, v, velocity is v here, and here velocity is v dashed. Okay? This instantaneous velocity, no, it will be tangential to the path, as I told you just now. Now what is delta V here? On this curve, delta V will be directed along this direction, because V this way, V dashed this way, this point be A and this one B, then AB is going to be V dashed minus V, that is delta V. Okay? So delta V by delta T, that will be along delta V only. So average velocity, average acceleration is directed along delta V. But if we approximate, one thing, just let me simplify it first. You write delta V vector is what? Delta V vector, you can write velocity as component, no? Vxi plus Vyj. So delta V vector will be delta Vxi Vyj. So write here delta Vxi cap delta Vy j cap. Okay? So if we write A average, then this will be delta Vx by delta T I cap delta Vy by delta T j cap. This is what? Average acceleration along Ax I plus Ay j. Ax, Ay are what? These are average accelerations along x and y axis respectively. These are average accelerations along x and y axis respectively. So Ax, what we have taken? Delta Vx by delta t, Ay is delta Vy by delta t. Instantaneous, how to find? For instantaneous acceleration at a point that I am going to show you, for instantaneous acceleration, I am just writing A for that, will be limit delta t tending to 0, delta Vx by delta ti plus delta Vy by delta t c. So this is dvx by dt I cap, applying derivative concept here, plus dvy by dt j cap. Okay. So by knowing the component of the acceleration, this component we can take ax and this one ay. What ax stands for? Ax equal to dvx by dt, component along x-axis, ay equal to, that is component along y-axis. And by this method you can easily find the magnitude of acceleration and its direction. Ax, this is along x-axis, I cap here, y-axis j cap here, and this is A. This angle be theta. Then what's the value of mod A? Mod A, as we know the rectangular components, it will be ax square plus ay square, and tan theta will be what? Root of ay by ax, so theta will be tan inverse ay by ax. Okay, definitely you can get the value of acceleration and its direction in this method. Now if we want to see what is the direction of acceleration on the curve, let me take an arbitrary one. What I have taken before, I need not take. This is true for any curve. Taking this method. At this point, at the point A, velocity is v, and at the point B, velocity is v dashed. What is the direction of that velocity? You know, it is tangential, isn't it? At this point A, velocity is tangential to the path. Like this is the direction of v, and at the point B, this will be tangential only. That is like this. Okay, this is the direction of v dashed. Now to find v dashed minus v, what we'll do there, first we'll shift the vector v over there. V is taken over there. At the place of B, we take the direction, we take the velocity vector v. Now produce this one in backward direction. Okay, this is minus v, and then complete the parallelogram, because you know the diagonal of the parallelogram will represent that v dash plus minus v, it will be represented by diagonal of the parallelogram. So this is the direction of v dash minus v. It is not perpendicular to the path, but direction will be like this. Okay? This way you can understand. Never say that acceleration also will be tangential. Instantaneous velocity tangential, instantaneous acceleration also tangential. It is wrong concept. The direction always you have to get by this method, and on the curve you understand this way. This is the direction of acceleration, because this is delta v then, no? So when you are writing a equal to limit delta t tending to 0, delta v by delta t, or limit delta t tending to 0, dv by dt, dv del v has the same direction. So acceleration will be like this. Maybe perpendicular in some, but not always. Okay? In equal to 4. So how to get? You write Vx first, xt given. So Vx is what? Just we have learned dx by dt, 3t square, y is 2t square, dy by dt is what? 4t. So you got Vx and Vy. So write the expression for V first. V equal to what? Vxi, Vyj. Okay? Now, if you put Vx and Vy over there, it is going to be 3t square I plus 4tg. Isn't it? Now, this is velocity after time t. So, how to get average acceleration? Average acceleration is difference between two velocities divided by time. So, average acceleration will be v4, v at time t equal to 4 seconds, minus v0, that divided by 4 minus 0. What is v4 here? You put 3 into 4 square I plus 4 into 4 j, and t equal to 0, both the parts will be 0. 0i, 0j by 4. So this is going to be what? 48i. So this will be 12i plus 4j. Isn't it? The value is 12i plus 4j. This is the value of average acceleration between the time interval t equal to 0 and t equal to 4. Mod A average you can find 12 square plus 4 square, 4 outside, 4 into root 10, and the angle direction, how to find? You know the components. So, tan theta with x-axis will be, this is what? AXI, AYJ. So, AX part is 12, AY part is 4, and this tan theta going to be equal to 4 by 12. So, theta equal to tan inverse 1/3. Simple. You understood how to calculate the acceleration, the average acceleration between two given time intervals. Now, can we extend the concept in 3D? See, NCERT 3.17 question they have asked, a question where k vector is given. If we do it by IJK method, this will remain the same. If we do it by component method, then acceleration vector you will write AXI, AYJ, AZK. Okay? And by knowing the components, you can get all the values very fast. It is same as that of 2D. Here it is given 3ti 2t square j 4k. Now you find v vector first. Dr by dt 3i 40j and this one 0. Acceleration how to get? Acceleration is dv by dt. This is going to be minus 4j. Okay? So velocity and acceleration you got. Expression for velocity is what then? V equal to 3i minus 40j. If time is given, you can find the components and get the direction. But time not given, we are not going to find it and not required in the problem. Now the question is maximum direction of velocity of particle at t equal to 2 seconds. For the next part, it is given. Then when t equal to 2 seconds, v going to be 3i minus 8j. Okay? Then mod v will be what? 3 square plus 8 square root 73. Let me calculate this. Using calculator, that root 73 is coming to be 8.54 meter per second. And how to get the angle? Because the velocity vector is now 3i minus 8j. This component Vx equal to 3 and this is along negative y-axis. This Vy is 8, opposite direction, that y-axis this way. So how to get the angle? Angle with x-axis you can easily find. Tan theta going to be what? 8 by 3. Let me calculate this again. Approximately 8 by 3 around 70. Okay? So hope you have understood this session. This is important for concept clearing, not for solving sums. Motion in 2D is a beautiful concept in class 11 physics. I have tried to deliver my best to explain it to you. Thank you for staying with me.